All right, so let's get started. Hi everyone, my name is Virginie. I'm very excited to be introducing our very first Robotiq Physical AI Roundtable. Today on the Roundtable we have Jennifer, AI Specialist at Robotiq. We have Marianne from Franka, Michael from Universal Robots, Chris Paulson from NVIDIA, and we also have Samuel, our CEO at Robotiq, who's going to be moderating the whole conversation today. So, Samuel, over to you.
Thank you for the introduction, Virginie, and thanks everyone for joining. We have a very interesting panel today. We have people who have really interesting viewpoints into the physical AI ecosystem or ecosystems in the different regions in the world. And that's what we want to explore today. And you know, it's happening extremely fast. Everything that's happening in physical AI these days. And I would really start there because it really feels like a race. It feels like we're all racing in that physical AI race. But what is the end goal? I would like to start there. What is the end goal? What do we want to do with physical AI? And maybe I would leave it to Chris to begin with. So of course, NVIDIA is kind of at the center of this whole ecosystem. So Chris, what's your vision of what is the end goal with physical AI?
Yeah, so I think we've seen an explosion of physical AI in probably the last 2 years. You know, with the emergence of sort of VLAs coming to the scene of being able to teach robots using data to go off and do otherwise tasks that couldn't previously be automated has sort of unlocked a lot of I think excitement about how we can take robotics forward. Of course, at the same time, you have humanoids, new embodiments emerging that sort of give you new solutions to the robotics problem. And so I think kind of across the ecosystem, whether you're talking about a 6-axis arm by manual manipulators or humanoids, we're seeing a convergence onto these sort of robotic foundation models and other approaches that are really data driven, that allow you to build really robust systems that can go off and solve pretty technically complex problems. And so there's a lot of technology that's been building behind the scenes for probably the last decade to enable that through simulation. We have large language models emerging to allow for VLAs. Now we're moving into sort of the world action model, regime of how you start to build and train these models using sort of internet scale data, and then how you apply that to physical robotic systems. And so I think we're seeing sort of the first moment where it's coming together end to end. I think NVIDIA just released at GTC Taipei or Computex, the first end-to-end reference architecture for a humanoid robotic solution, and that was based around a Unitree humanoid platform, but it's the first time that we've been able to pull together the full stack where you can train in simulation. You can train controllers for robots. You can then teach a robot how to go off and do a task and then deploy it in the real world on physical hardware. And just because it's on humanoid doesn't mean that we haven't solved other problems along the way. That same reference architecture is applicable to 6-axis arms and bimanual manipulators. And so we're seeing sort of the first time where these are going out into the world. And if you just watch the news around sort of the investments in the space and the new companies emerging, there's a tremendous amount of excitement and a tremendous amount of capital flowing into this right now to sort of also enable the physical side and all of these companies to go out and be successful with all of their various approaches to robotics.
So Chris, thanks for the overview of all the exciting tech coming together, and obviously tons of investment. It's really crazy, and there's not a day that passed without a massive investment announced in robotics. Mike, at Teradyne, you guys have been deploying robots for a while. What do you think, coming back to that question of what is the end goal of physical AI, what do you think physical AI will enable that you haven't been able to achieve in the past?
So I like this question because I think, to your point, right, earlier, we're in a race, we're heads down, but stepping back and looking at the overall, what are we doing? What's the goal of what we're doing is a good thing to do. I don't think that the goal with physical AI really changes the mission much of Teradyne Robotics, right? The mission of our company is to have people work with robots, not like robots. And so I see AI very much as a tool to enable that mission, right? To enable people to work more simply with robots than they have in previously. So to your question about what does this tool suite unlock? I mean, I think it unlocks even wider range of applications that are very, very challenging to solve with traditional, point trajectory programming. A very good example would be, to your point, right? Like by manual manipulation, or if we're handling things that are deformable, if we're routing cables, if we're if we're doing any sort of thing where we need real-time adaptability, that makes it very hard for, I guess, traditional, deterministic programming methods to work. You need that ability to react on the fly, right? So I very much see this being a tool set in line with the mission of Teradyne Robotics, which is to have more people be able to use robots simpler.
Thanks, Mike. So, Marianne, on your side, Franka has been almost the de facto standard in a lot of the early work in terms of model building, in terms of having robots to learn the physical world. This is a mean to an end. Ultimately, where do you see physical AI going once all of these models are being built? What will the industry or the industries will be able to achieve with physical AI?
Well, I mean, for now, in the last 30, 40 years, we saw that we created deterministic robotic cells, like cells around the robot, which always have a very deterministic state. I think the potential now with VLAs and foundation models is that we can get rid of these deterministic states and get a more flexible state. So we don't have to adapt the environment to the robot, but the robot is actually adapting to the environment. And I would say the potential that we can leverage there is great. Let's see where we're heading to.
Yeah, and for those who don't know, we had a side discussion recently in Munich, Marianne, where you mentioned that your father used to work for one of the biggest robotic system integrator. So ultimately, they deployed a lot of robots in a lot of factories, and now you're kind of tackling the challenge and just bringing that new phase of robotics. Is it still the end goal? Is it still to deploy robots in factories that we want to do and just do it in different tasks, or it's going to go beyond that?
Definitely. I mean, as I said, like we were able to use those industrial robots in the cells because we were able to define the environment the robot is actually acting in. But with this new technology, we don't have to do that anymore. So we can use these robots now also in environment where they get in, where they have to collaborate with humans, where they have to find their own solutions on problems in a street environment, for example. And so we'll definitely see that AI will enable robots to interact with the human environment, the environment that we created over the years, and they're not bound to any enclosed cells in some factory shops anymore.
Yes, I think that's an interesting point. We'll revisit a little later in terms of having robots to adapt to the human environment. So we can explore maybe some of the form factors that are being proposed by the industry right now. But maybe I would like to jump to another question. So Jen, you've been on the roll, you've been visiting a lot of companies active in physical AI in all the hotspots around the world. So you've been everywhere in Europe, China, and in the US as well. I would like to know from your point of view, how the different regions approach the physical AI problem differently. What have you seen different from one region to another?
Yeah, it's interesting to start from the thing that I see that is consistent across the region, which is speed, which is you have to go fast. And what they're going fast towards, I think, is what differentiates the different regions. So China has been very fast at having something you can buy, right? You have Unitree as the kind of first humanoid robot that you're actually able to purchase, and we see with what Chris has mentioned that that's paying off. Now there is a full stack reference platform built for the Unitree humanoid that someone can go and buy and deploy right now today. Agibot, also a Chinese company that has, I think, the highest humanoid deployment right now. So for that region, it's the speed of having hardware that you can buy right now, which has been very exciting to see. In kind of the Bay Area, I think it's the quality of the models that there has been this speed and this ability around. So really focusing on having these really, really powerful foundational models that people are then able to leverage onto their various hardwares. And then in Europe, I think there is a lot more focus on the application side, I think, compared to some of the other regions that I've seen. That the German companies are really focused on, okay, what are the industry problems that we want to focus into? So for me, that seems to be a little bit of the differences between the regions. But I think in all the cases, there's obviously, depending on the company, there's overlaps. But everyone is focused on going fast is certainly what we see.
So speed is definitely a theme in physical AI. When you go fast, you need to close the loop in your control, because you can go fast in crazy directions and head into some dead ends or head on a wall. So who's using the right type of feedback? So you talk China, you can buy stuff now. Europe more applications, US still more at the model level, but probably the highest quality of model. So open question to the group, who has the right approach in your opinion with respect to developing, but also getting feedback in order to iterate and get to the end goal of deploying physical AI? Who wants to jump in?
I can take a stab. So I think, they're all complementary, right? So at its core, robotics is a data problem. So if you want really high quality robotics, you need a tremendous amount of data. That's everything from simulation to physical demonstration to robots in action. And I think, data requires a couple things. For starters, it needs that sort of initial kick, right? So you have a cold start problem when it comes to data. We've been solving that through a lot of different ways, internet scale data for training sort of like foundation models. We have quite a lot of ego scale data now, and that corpus of data is growing quite quickly. And so we're able to now start to sort of build on that. And then I think the next step is in robotics, the only time that it actually matters, performance matters only on robot. So up to a point, you can train your models, you can run it in sim, you can do all of your evaluation, but the only place it actually matters is on robots in the physical world. And so I think we need a large number of sort of robots to go off and run these tasks. And for a long time, 40 years, robots were deterministic. They had a different controls philosophy. And so, a lot of the robotics out there weren't quite adapted to sort of the ways that we're using robotics now. I think in the last 5 years, we've probably seen a pretty significant change in robot topologies, the philosophy behind the control systems on those robots and how to use them. Obviously Franka and you were some of the sort of early adopters of like what happens if we unlock the control system and allow researchers to get a lot closer to the motors and controls than they would have otherwise been able to. I think we're starting to see that accelerate through the humanoid world as well. And so I think you have this kind of combination of scale happening, and scale happens primarily in China, but it's happening elsewhere too. So we're getting a lot more robots out there. We now have enough data to sort of get to these really good foundational models, and we're at a moment where we're connecting all of that together and taking that out to the industries. And I think robots, intelligent robots functioning in industry is going to be the next major unlock in terms of how do we get to that next level of performance on these robotic systems. So it's not going to be one of those subsets winning. I think it's how that all comes together globally, and we deploy robots kind of across the world.
Yeah, I think that's well said, Chris. To sort of take. To take something that your CEO has said, I think he's brilliant. All the layers of the cake have to work at once, right? So I think intelligence, I just had a talk on this at the Automate trade show. I think intelligence is not alone the answer. And I do see a lot of people, believe, hey, I just need the best model, or I just need the most capable model. And there's really what we're talking about here is systems engineering. If you're trying to get a intelligent robot operating inside of a factory line or in a process or something, that really is a problem that we've always looked at with just the new layer of intelligence. What's the model going to do? How's that going to enable the robot to be adaptable, right? But absolutely, I mean, some of the big concerns, I mean, are not concerns, but things that have to be right are also security, right? What happens with the data we collect? Like, where does it go? That goes into this question, I think, that's going on, especially in the United States right now around China, around like, you know, the stuff that's coming out of China. What do we do with those tools industrially? Yeah, there's a lot of pieces that need to work all at the same time in order for this to really truly be viable outside the lab.
So you're absolutely right. I totally see this huge task in data collection. I mean, for ChatGPT and Claude and so on. I mean, we were gathering data for 40 years in the internet. So this is the data we can use for training. It is out there. It is available. For physical AI and specifically robotics, it's a whole different thing. It's most of the companies in the last decades were just protecting their data rather than sharing it. So we need to produce them. But there's also one side I would not forget in this picture. And this is the embodiment. And this is actually also a huge bottleneck that we must not forget. Specifically regarding what's the observation space. I mean, if I have the observation space at all is what the AI is able to perceive, what it understands about its environment. If it's a camera, if it's tactile information on feeling, if it gripped an object, if it's pushing against something. And the action space on the other side is the ability of the embodiment to interact with exactly this environment it perceives. And this is the huge task that I guess a lot of people are forgetting, that this is something we definitely need to have. Otherwise, we can collect tons of data, but we are not able to perceive the environment and to interact with it. And the other task that is bound to the embodiment is also something that a lot of people are not mentioning or are not seeing at the moment, I guess, is that if you have a good embodiment, you also need to be able to produce it in scale and in a reasonable cost. And this is something that we will see will get more and more important in future, next to the data generation topic as well.
So, Chris, you started by saying that robotics is the data problem, and then we had Mike and Mayad said, yes, it's data, but not only data. Mike, you talk about system engineering. Marianne, you talk about the embodiment, so the other types of data. Do we have an agreement that robotics is a data problem, or we have people disagreeing around the table here, that it's not only a data problem, even though data is a bottleneck right now?
I think we also have to realize that there is maybe architectural problems and system problems as well. I think VLAs have been really, really powerful and exciting, but it's not necessarily the best tool for every job. And we are trying to overcome those gaps with more data. So is it a data problem, or is it a combination of data and the right tools and the right systematic approach? And we've been talking about having the right embodiment, doing the right tasks, and as Marianne kind of poked to, the right perception stack. And if you have different perceptions, then that can open up different architectures that might be able to close the data gap. So I think there is a combination of other factors as well, and it's not just data, but correct perception, correct task definition, and maybe the correct architecture and models as well.
Yeah, that's well said. I mean, the expression I like to use is you don't throw your hammer away when you buy a screwdriver. They're different tools, right? They do different things.
I would like us to wrap our head around data. So Marianne, you talked about the amount of data that was available to train the LLMs. Maybe another problem that might be a little bit closer is the autonomous driving that also gathered a ton of data for free by having cars driving around, not for free, but by having cars driving around and capture a lot of variety of data and a lot of quantity of data. How does that compare to the data that we actually need in robotics, and do the actual way of gathering data, will these way of gathering data get us there? Or right now we're kind of using tools that will never get us there and we need to really find new things?
This is the very big question at the moment. I mean, every researcher is asking exactly this question: are we gathering or are we collecting the right data? On our side, we collected a lot of real-world data. We are still collecting it. There are tons of robotic farms where you have a teleoperator doing the same task again and again and again, and there are hundreds and thousands of them. It is, and this data is probably one of the most accurate ones, because specifically for one embodiment, because you do have the application, the robot is actually doing the right application, and you do get the exact data of this robot. But on the other hand, it's also one of the most expensive ways to collect data. And the question is that sustainable? Do we get enough data to be able to train a model doing exactly this task flexibly? And my point of view is that this year, and specifically next year, we will see more and more simulation coming up. Simulation that builds up, or like that is very accurate in any kind of way of controlling the robot. That's very accurate in the observation space it offers. Means camera data, collisions, efforts, and all of these kinds of data. And that is able to learn in its own environment. So specifically reaching out to world models and stuff. When we were babies, we had, how to say that, we were lucky that we grew up in a world with a physical rules that we have to interact with. But in simulation nowadays, we are trying to mimic these physical rules by calculation. If we will be able to create like a world model where the robots can learn the same way as we did as when we were small, it will be way more effective. But we are definitely not there yet. But let's see if something like this is coming up very soon.
I think So I agree with you. I think well said. For the majority of my time with Universal Robots and Teradyne Robotics, I've lived in the industrial world and deployed robots into our users that are using these traditional programming techniques we've described, right? I think the challenge, right, around data. So data is absolutely part of the problem, and the big challenge around that is going to be obviously all the things you said, Marianne. But also, how do you actually capture all of the edge cases, right? Because if you imagine your data as dispersed across a bell curve, you have enormous tails that are going to exist in the industrial world, and these are edge cases that potentially stop a line if they're not correct, if the robot's not able to handle these, right? So, from the people that we work with, what we see most often, it looks like a combination of data inputs, right, is what's giving the model sort of the capability to be very adaptable. I don't know if I see overwhelmingly one data source as the data source, if that makes sense, right? I think it's going to be a combination of simulation data, because time is immutable in sim, and you can run millions and millions of cycles that you couldn't do otherwise, right, on a teleoperation rig. Telemetry is going to be important for what you described, Marianne. I think you're obviously getting high fidelity data off of the robot. Again, the limitation on both of these, though, is that you're only training on what you're training on, if that makes sense, right? How do you capture the edge cases you're not predicting or preparing for? That will happen industrially, right? And then obviously, Chris, you mentioned the ego or exocentric data capture, and I think that's obviously critical as well. So, I guess my own perspective would be, there are some pretty enormous tails we're going to have to cover, and it's going to be combinations of data streams that are going to need to come into these models to round them out, right? To give them as much tail information as possible, because that is required for a viable deployment, right?
Chris, I'm sure it's music to your ears to hear people talking
Yes.
about simulation.
Fantastic.
And it
Yeah.
makes a lot of sense. At the same time, I'm also hearing a lot of complaints that the physical simulation is not where it needs to be yet. So can you help us understand what's coming up, and when will we really be able to do, like Marianne is suggesting, to really train our robots in a physical simulation that's close enough so we can have high number of data from simulation, but get closer to the physical reality?
Yeah, so I think there's two parts that I would sort of call out. The first is that if you look at, let's take the NVIDIA story. So Isaac Sim, Isaac Lab, it really came from NVIDIA's efforts in the video game world. So that was based on our physics library. It was really focused on how do you do so large scenes, fairly gross contacts. And as you start to move into sort of the world of robotics, where you're looking at very fine-grained dexterity tasks or very nuanced things, like all of a sudden we realized that there was probably a need for a new physics engine. And so we have been, making very steady progress on Newton, which is a super exciting new physics engine for us. GPU accelerated very fast, allows for large scale reinforcement learning, but at the same time, it allows for a lot of different solvers to be used within, a specific simulation environment. So if you have a robot that's walking on, let's say, granular surfaces, or even thick carpet or something like that, you can now simulate it. If you have a tactile sensor that has a squishy fingertip and you want to understand real-time pressure distributions on that finger, you can now simulate it. And at the same time, you can still simulate, robots, kinematics, and all of the normal things that go along with it. And so I think we're seeing tremendous progress there in terms of how do we get these sort of new physics models and new solvers into the simulation. I think we'll continue to see a lot of improvement there as it goes. But the other thing that I think is probably also a huge unlock is sort of the agentic era. So a lot of times simulation was really limited by the assets that we had and the time it would take to build a scene. What we're seeing now with sort of Claude Code and all of these agentic approaches to how you can go off and basically very quickly have agents build sophisticated scenes and mix these things together, run simulations and do that in a way that is human out of the loop, I think is going to be a super exciting time for collecting all of the data. And I think it applies broadly across robotics, but I think in simulation where, if you can give Claude Code access to, 30,000 GPUs and a bunch of assets, that it can go off and actually be highly successful in building worlds, running robots in those worlds, and creating corner cases that we can't even dream of. And so I think we're going to see a pretty massive unlock there in just sort of the operational use of simulation. Across the robotics platform, obviously like auto learning, auto research for learning, tuning, and all sorts of other things are sort of on the horizon that we see being ultra promising. But, we have seen some pretty tremendous work in like scene generation and task assignment in simulation using agentic approaches.
That's super exciting. To be able to have all those scenes being created by agents, it's kind of mind-blowing. At the same time, the real world is also pretty fantastic. And we talked about the fact that we want to get real data from real robots. Just like, again, autonomous car got from real cars driving in real roads in real conditions with unpredictable stuff that happened. Is it at all possible to connect all of these robots and gather all of that data, considering where they're sold, the type of user, the type of data, the security questions? Do you think we're going to get there at some point?
So I think there's going to be a combined story. I think there's going to be companies like NVIDIA and we publish things like Groot and Cosmos is really like the foundational jumping off point for companies to take and build on. We want to make sure that we get as much data built into these foundational models to allow everybody else in our robot ecosystem to go off and be successful building on NVIDIA tools. So we would love to collect as much data as we could into models like those. At the same time, we understand that there are always going to be air-gapped applications and sort of applications of a proprietary nature that will have to live within a company or a country or whatever that boundary is. And so I think, we may never have like the universal data set for robotics, but certainly I would hope that we could get to a point where all embodiments are well represented in shared global data sets, where these sort of core foundation models can be used to adapt very quickly to any embodiment in any environment. I think that would be like a really, really good goal. And then from there, you can basically fine tune, a model to meet your specific need and your specific throughput use case.
Mike, you've been selling in industry for a while at Teradyne. You have tens of thousands of robots out there. Do you think that with what AI is going to enable, it's going to help people make that decision to finally connect their robots and share some of that data to keep continuously improving and open up new use cases?
That's a good question. I was thinking as Chris was talking there about different customers I've encountered and just, what the thought is, right? I think that the flexibility, the capability set that comes with a model is going to be enticing, right? I think that users are going to say, what I can do with an intelligent robot is attractive and is maybe worth, a connection, right? I think it's worth sharing data. What Chris said is absolutely correct. There are absolutely customers, applications, industry segments where that's not going to be feasible, right? For one reason or the other. But I do believe that intelligence will be an enticing thing for our users, right? I do think that intelligence is going to prompt a lot of users to say, yes, it's worth connecting, right? I think that the challenge there is going to be the interaction point, right, between the user and this new intelligent robot, right? Universal Robots has spent an enormous amount of time and effort over the last 2 decades, building a platform that's approachable. And we think that accessibility and that approachability is what's helped, put Universal Robots into the place that it is globally. And I think that interaction point between human and machine, and how does a human actually enable the intelligence, and whether that looks like, prompting in natural language, or if that looks like teaching by demonstration. These things are still sort of out there as methods, but that's going to be really important, right? So it's not only, hey, what can the robot do, but also how do I get it to do the thing I want it to do? That's going to be really, those two things have to work at the same time, in my opinion.
Yeah, definitely. And we started the discussion by wanting to compare the ecosystem. We went down that rabbit hole of data pretty deep, but it seemed like it's still at the core of the challenges that we're facing. If we want to connect it back to how people are using data, so we talk about data quality, we talk about data quantity, connecting it to the real applications. Again, Jen, what have you seen in terms of the different regions, but also the different type of companies? If you compare humanoid robots to people using more mature platform, who's making the best use of data right now, and who's moving faster in building their model with the data that's available?
Yeah, that's a very difficult question to answer, but I would say there is definitely those two approaches of having that kind of general model approach and the more application specific approach. And the embodiments in which the companies are doing that, it depends on the region and the company. And I think this kind of goes a little bit to kind of what Chris was mentioning before, is at what point is your foundational model good enough that then you can have it deployed on a specific application with a small amount of fine-tuning of real application data to have a full usable product that someone will buy and get their ROI within an adequate time frame. And those are I think the questions that all the different companies in all the different regions are still asking. And yeah, I would say that it's hard to break it down specifically by region because it's really by company of which companies are choosing to put their money into what basket. And I think each region has a bit of a spread of these foundational model companies and these application model companies. And yeah, we need both. We need that real world data, and we need these models. And it's really going to be the companies that are able to put the two together into something that works and that's something that people trust, right? It's not even it worked 99% of the time, but the users have to like it. Going to like what Mike was talking about is, how am I able to use this as someone who is not a roboticist, who is someone with a logistics warehouse? Can I buy this robot and put it in my factory, and within a day it's working, and I understand what it's doing, and it's if there's an error, I understand what the error is. I can call the support line and have someone come and help my robot. There's all of these other things around not just the model or the approach that will make it an actual product. So I think that's what we're going to see differentiate the companies, is who can take these different things and put it together into something actually functional. The operational level of the physical AI, and it's going to be a combination of both. And it's not clear who is a leader in that yet. I think the one company that I see really taking that approach is probably Agility in the States. That seems really focused on having that full stack of good foundational model and deploying in the real world, and really focusing on how do we make this an operational product. At least the one having the most kind of noise and talk about.
So let's explore that topic a little bit as we get closer to the conclusion, because we hear often, I'm sure you hear that as well, that question of, hey, has robotics reached that ChatGPT moment? And I really roll my eyes when I hear this, because to me it's totally different in the sense that the distribution for LLMs, it's instantaneous, it's connected to the internet, you have access to billions of users with your web interface. This is not the reality with robotics, with physical AI. You need to actually deploy these things physically in a highly fragmented, so many different places, environment, factories, or even other types of environment. So the distribution and the deployment aspect, do you believe that, or do people see that challenge? The people building the models, the people building the applications, do they see that deployment challenge on the horizon?
I believe so. I hope so, because I couldn't agree more with you. I hear the same thing, Sam, and I agree with you. The physical world is different than the cognitive world, right? I think that where cognitive AI has been with LLMs is there's a ton of overlap, of course, right? That's why VLA is very much an overlap into the physical world, but the physical world is a challenging environment. There's again, the tails on your edges are enormous, and you got to be able to deal with all of them. I think that ultimately what's going to get this right is, again, a combination of the right inputs, the right middleware that connects the actual operators, the actual physical world to what's going on inside the robot. There's a ton of pieces that need to come together all at the same time in order for this to work. And then I think, going back to a comment Jen made earlier, right tool for the right application is going to be really important. So the big thing that I see here, and part of what I try to do in my own role within my organization, is a lot of education about just how do robots today interact with people today industrially, right? Our focus at Teradyne Robotics is the industrial world. That's where we've deployed a lot of our robots. And it's going to be critical that people understand, right? Like how does someone program a robot? How does someone program an intelligent robot? How would someone that is looking to deploy an intelligent robot to an application collect the data for that application, right? There's a lot of pieces that are going to have to all come together at the same time. And I think the model builders and the folks putting humanoids together and NVIDIA and all of these teams will need to do education for... Everybody has to rise up and understand what's changing all at the same time. It's not going to just be delivering the most intelligent model. It's going to be delivering an intelligent model that also has, also has some ability for your operators to interact with it in a way that they understand, right? Because if the bottleneck suddenly shifts down to, I have got the most intelligent thing in the world, but no one knows how, but only PhDs can use it, it's going to be very hard to democratize a solution like that.
So everybody's going to need to participate, and we have new players entering robotics. So we have the model builders, we have new application builders. NVIDIA is now an integral part of the robotics ecosystem. It's going to reshuffle who does what and who captures what value. How do you see this going forward, Marianne? Do you think that the role of the robot makers, the system integrators, the model builders, who's going to capture what value and who's going to be in charge of the deployment ultimately?
Very good question. I guess that's my guess. We will see a split there. We will see companies focusing a lot on creating very accurate, safe, and with high fidelity embodiments. So this is something we have tons of big companies, for example, also here in Germany, which their business cases, let's say, it got difficult in the last years, and I'm pretty sure they have all the capabilities. They have the production capabilities. They have the knowledge in designing good embodiments. They will probably shift towards exactly this topic, creating very good embodiments for the physical AI world. And then we will have the other side that is more focusing on creating the data, doing the deployment, and fine-tuning the models for rather very specific applications, or creating models that are so generalistic that you can almost tell them exactly what to do, and they will control the robot to do exactly that. I guess it will be this split, and this is also the question. Like, we're coming back to the question of the regional focuses, that areas that were always good in manufacturing will rather focus on embodiments, and others that were always good in creating software, creating data, will focus on this part. And I would say it's a good mix. Everyone will rise on these topics.
So thanks for sharing your guess, Marianne. As we close the discussion, maybe what I would like is do a quick round, and if each of you could share an insights, maybe something that's a bit contrarian. Again, try to break the group think that's happening sometimes too much in those high-speed tech environments. Any insights you want to share that you believe the rest of the physical AI industry should think about? Chris, you want to start?
Yeah, sure. So I think we're very excited about the future. I think we're seeing acceleration. I think we're seeing some pretty amazing things coming out, both of our internal research labs, but also across the robotics ecosystem. We see VLAs going into production, right? I mean, Pi 0.5 was released a year and a half ago, and already we're starting to see commercial use cases where it's viable to go and take these brand new technologies and put them onto the production floor. I think there's going to be a challenge of making sure that we find the ROI for a robotic system and intelligence and sort of end use. And so I think making sure that we keep track of probably two things from the model builder side, recognizing that the system cost to automate something is the same as it always has been, but now there's a cost of intelligence on top of that, and that has to sort of be accounted for. How do you price that intelligence? What is that system actually bringing to market, and where does it fit? And I think on the flip side, the end users of robotics have to also understand that these systems aren't the same automation that you bought 40 years ago. These systems are intelligent. You can adapt them. They grow with you. They expand with you. They have the potential to get, the Elon Musk over-the-air update that they just get better overnight. And so I think there needs to be sort of a shift in mentality about how you value that type of system, because it's not buying a system for a specific task on your production line anymore. You're buying a flexible manufacturing system. That system can grow with you, can evolve with your company. And so you need to price that in. Intelligence does come at a premium. And I think there's going to be a balance in finding just the right moment in time and sort of the right balance between both the buyer and the seller from this intelligence perspective to make the whole picture work in a really big way. I haven't seen like a really clear convergence on that yet, but I think that's going to be something that basically both sides have to sort of be cognizant of as they push this new technology to market.
Thanks for the insight, Chris. Mike, what would be yours?
So I think maybe I'll go down the controversial route, I guess, Sam, for your suggestion. I think that embodiment is going to be really, really critical, and it's going to be related to right application, right tool. There's a huge amount of noise about humanoid. Teradyne Robotics is not anti-humanoid. But I think, when you're considering a bipedal robot versus a mobile manipulator, a wheeled robot, especially for industrial use cases, there's many, many applications that are very well served for, an AMR with a couple of robot arms that are on its back, right? Doing some sort of flexible bimanual manipulation task. So I think the humanoids are phenomenally, it is, in my opinion, it is the future, right? However, right tool, right job, and mobile manipulation should not be overlooked, because it can, again, going back to that ROI piece that you brought up, Chris, that's going to be important, right? Do you deploy a bipedal legged robot to go and do a job that is essentially in a warehouse style application or something where floors are flat, and mobile manipulation works just fine. So encourage the industry to not forget mobile manipulation.
Thank you, Mike. Jen?
I think, mine would be in a similar vein to Mike's, but maybe just on the intelligence side, is that we have decades and decades of research in automation and in AI and machine learning that I think sometimes feel like it's been thrown into the garbage because we have VLAs, which have been very excellent and have kind of progressed the field a lot. But there is so many things that have already been done that work very well and can be scoped down to specific applications to build out a product where you're leveraging just enough physical AI and all of these other tools and approaches to maybe make a system that is more robust and more deterministic, because it's not necessarily, okay, this was the most intelligent system, but is this the most reliable and predictable system? And just being cognizant of what parts of the workflow that you're creating need AI and which ones maybe you can put other things in. That would be my advice to the industry.
Thanks, Jen. So again, the idea of the right tool, but more in how we actually design the system. So, well aligned with Mike. Marianne, what would be your insights you want to share?
Okay, same on my side. Regarding the embodiment, why it will be way more important, as Michael said, as we think. One thought about it. I mean, the reason why we humans got more intelligent is the hand. And it sounds weird, but this enabled us to interact with objects. We can feel with them. We can. It's a high fidelity instrument, and we are able to build tools. We are able to use these tools to create other things. So this forced us to get more intelligent, to have a bigger brain and all of this thing. And I think we are also on a stage at the moment where we should think maybe we should definitely have a closer look to how to enlarge, to enrich the observation space and the action space of our embodiments, and still how to be still able to produce those in scale and in a reasonable price. This is definitely the challenge that is coming in the next years, and I'm really looking forward to play a part in it.
Thanks, Matt. That's a great conclusion. I didn't even pay you for that, but it's really well aligned with Robotiq's vision. We strongly believe that intelligence goes beyond the brain. Intelligence is also in the body, and it's also bidirectional. So to build a good intelligence, you need a good body, and to deploy good intelligence, you need a good body. And again, we tend as engineers to, okay, this is the brain, this is the body, but in reality, there can be intelligence throughout the body, and it comes down to the design choices that Jen and Mike talked about. So super interesting. Again, we started on a topic, we drifted to many other very interesting topics, and it just have thousands of other questions I would like to discuss, so maybe we'll do a round two. But thanks a lot for your time and your generous insights. It's been super interesting, and we'll talk again soon. Thanks, guys.
Thanks.
Thank you.
Thanks, everybody.
Bye-bye.
Bye.